My dear friends, welcome back to Be Spice. In this session, we'll focus on HVAC DDC system. So DDC means Direct Digital Control System. Okay. So this is the look and feel architecture. You can have this controller, the standby controller, and all your fields are connected to this directly. That is the simple architecture, not like our DCS architecture, wherein we have the various hierarchy, right? So yeah, let's go into the details. In fact, what I'm going to bring in here, we'll talk about what is DDC, and we also talk about the terminology and theory of operation. Terminology in the sense the points, digital input, digital output, input, analog output, all this. And also we'll focus on what do you call the DDC hardware actually, what are all the hardwares involved, and also we'll talk about the control algorithm, what are all the inbuilt control algorithm, and we'll also touch upon a control network. Basically, the network means like, the architecture and the controller classification, right from primary controller to secondary controller, and also the LAN communication and the communication interface. All this will dive deep. Then finally, we will see the protocol, which is the backnet actually, backnet, and that also we'll talk. Then we'll wind up with the advantages of this DDC. Okay. So let's talk about the intro first. Okay. So as we know, DDC is a microprocessor or computer based open or closed loop control of an output device based upon input data. Okay. And sophisticated control algorithm, typically proportional, integral, and derivative, which we have in fact already discussed this in one of our video actually. Okay. If any of you are interested to learn about PID controller, you can also watch our channel. Okay. So this is a basic definition basically. It's a microprocessor or computer-based open or closed loop system. Okay, right. So the DDDC actually provides effective, sophisticated strategies for optimum control and efficiency. In simplest form, friends, simplest terms, it is basically a control system. DDC is a control system that uses memory, that uses a computer or many computers linked together via network that control the infrastructure of a building. So it basically consists of microprocessor-based controllers with the control logic performed by the software. Okay. So most systems distribute this software to remote controllers to eliminate the need for continuous communication capability. Okay. This computer is primarily used to monitor the status of the system, store backup copies of the program, and record alarming and trending function. And also it assists in complex strategies and energy management functions. Okay. And we have also central diagnostic capabilities. So this is about the overall idea, view actually. Now we go into the DDC terminology. As I mentioned in the intro part, see, there is a points. We call it as a points actually. See, normally in our DCS, we call it as IO point, right? So yeah, same thing here. They call it as a points. So point in the sense digital input, digital output, all these analog input and analog output. Okay. So now we will see the digital input and analog digital output. See, as we know, digital input is a status, which is either on or off, right? So for example, in case of an air handler and airflow switch, it provides a status on or off. Okay. And of course, digital input, other example includes two position, binary, discrete, or logical. Okay. Basically, the flow switches and static pressure switches. Then we have a digital output. So this is nothing but switches a device from one status to another or maintain a status. So if the control system is programmed to turn an air handler at 8 a.m. and off at 5 p.m., the digital output is the action of turning the switch on and keeping it until on the stop time. So that's about the digital output. Okay. Here in this case, we can say electric heater, fan, pumps, two position valves, all these. Okay. And analog input, of course, in contrast to the digital signal, this is either which is on and off. Analog signal can place equipment in range of position. Therefore, A is a varying or modulating signal that's sent to the controller. That is the point. Sent to the controller from the field. Okay. For example, temperature sensor, right? Okay. Then we have a analog output. So this is again a varying or modulating signal sent from the controller. Okay. That is the difference. Okay. Right. So with that intro, let us go into the universal points. There are also some universal points. For example, friends, while reviewing the local control unit, we hear that this air handler can have handle 10 points or the controller has 64 points. Okay. So this indicates how many connections can be made to sensor and control devices. Each controller has a maximum number of each point type. Some points have a fixed configuration, other points have a universal or adaptable configuration. That's what I am going to explain here. For example, fixed point. Fixed point means that dedicated to be specific type. Analog means only analog we can do it. We cannot change it actually. For example, a controller may have 4 AIs. So these AIs may not have to be used, but but they are AIs only. They cannot be changed to another type. But universal point, to address the problem of having fixed point that go unused, some point may be programmed as any of the 4 types, meaning analog input or analog output or digital input or digital output. So these are called universal points. Okay. So that's what I want to show here. And pulse input. So pulse input point type allows a controller to monitor the power consumption of a device such as chiller, fan, or air handler. Okay. So pulse inputs are used to monitor the power consumption of the whole building actually. That is the point. Right. So let us not go into that detail. Yeah, that's enough, I think. Let's go into the hardware part now. Okay. So the direct digital control loop consists of 3 main components basically. One is the sensor, of course, and the controller and the controlled device. See, basically, friends, the sensor actually measures the data, controller process the data, and control device causes an action. This is a field device, right? So sensors and control devices are connected directly to the processor, meaning computer. Controller function is to compare its input instructions such as set point, throttling range, and action, then produce an output signal. Very simple. Okay. So control logic usually consists of controlled response along with other logical decisions that are unique to the specific control application. This is about the control hardware, DDC hardware. Okay. Here, I want to also update you. The primary element for DDC is the digital computation unit. We call it as a MPU or a CPU. Okay. So what are the main components, subcomponents inside? So microprocessor, memory, input output multiplexer, analog to digital, digital to analog converter, then communication port. So these are the main components, right, friends? Okay. Hope it is clear. Now we go into this closed loop control. Here, the closed loop control is a important aspect actually in DDC control. See, as you know, the closed loop control, the control signal is sent from the processor to the control device, while the control device sends a constant feedback to the processor. Okay. So within the processor, the closed loop control signals are determined by control algorithm, configuration value, time schedule data, and set point schedule data. So basically, this control algorithm or mathematical calculation required to be performed by the DDC processor. Okay. So that is about the closed loop control. Of course, you know better. But the main point I want to update here is what are the control algorithm inbuilt? So there are many control algorithm inbuilt here. One is the heating and cooling coil controller. Friends, we are talking about HVAC, right? So DDC for HVAC. So these are the typical. We have a heating, cooling coil control, humidification, dehumidification, mixed air damper optimization, VAV fan control, VAV supply and fan tracking, indoor air quality and control point reset, time of day scheduling, discrete interlock. These are the some of the typical control algorithm. Few more: discrete staging, primary, secondary pump control, and also night free cooling and permissive interlock. These are the examples. Like for example, friends, a facility requires all the lights in the office block come on at 8 a.m. So they want to switch on at 8 a.m. So this instruction shall be programmed in the control system for execution. So exactly at 8 a.m. the next morning, the control system processor sends a signal to the control circuit telling the lights to turn on. And a sensor in the circuit panel sends a message to the processor confirming the action. That's it, friends. Very simple, isn't it? Yes. So then we go into the control network basically. Okay. So in the control network, we talk about the architecture. Okay. See, this is a typical architecture, friends. See, architecture is a map or layout of system used to describe overall local area network. So this map will, show where the operator interface, this is your operator interface with the system and remotely communicate with with the system. So the network or LAN is a media that connects the multiple devices, right? So you can see here, this operator station and controller 1 and controller 2 all are connected. So this, yeah. So the most basic task of the system architecture is to connect the DDC controllers so that the information can be shared between them. So this is simple architecture, but the main point I want to update you is on the controller classification. See, friends, controllers can be classified or categorized by their capabilities and their method of communicating. Method of communicating. In general, controllers can be categorized as high-end primary controller and low-level secondary controller. Okay, so that's it. Basically, the levels describe where the controller resides within the system architecture on the control network, which is judged by the importance of its application actually. Okay, let's see primary controller. See, basically, high-end controller normally reside on the higher level network. These are the primary controller and communicate in a peer-to-peer fashion. Peer-to-peer fashion. So these are called primary controller. Peer-to-peer means that controller can share information to other peer-to-peer devices without going through an intermediary device, like a supervisory device. Okay. So yeah. Okay, let's see the primary controller's features. Real-time accurate clock function, full software complement, larger total capacity, support for global strategies, buffer for alarms, messages, strand and runtime data, free-form programming, downloadable database, higher analog or digital converter resolution, built-in communication interface for PC connection. Okay, so these are the features of primary controller. Okay, as I said earlier, there is also secondary controller. Secondary controller means the low level controller. Okay, normally reside on the lower level of the network. These controllers are more limited memory and processing capabilities. And this guy might use a supervisory interface device to communicate to other devices. It's not like a peer-to-peer. Okay. So when we talk about the features, not necessarily 100% standalone, limited software complement, smaller total account point and free form of application software, and typically lower analog to digital converter resolution. Trend data not typically stored at this level. Okay. Typical application is a terminal equipment or a small central station equipment. So that is about the secondary controller, friends. Okay. And yeah, additionally, we have a LAN communication also. Yes, which I already told, right? So the controllers and all devices on the network communication can be characterized as peer-to-peer. Okay. So the controllers on peer-to-peer LAN may be primary or secondary controller. Okay. In a polling controller, like peer-to-peer controller LAN, the individual controller cannot pass information directly to one of the other controller. Instead, the data flow is, flow from one controller to the interface and then from the interface to the other controller. We are talking about the primary, what do you call the secondary controller, okay? Lower level. That is about the LAN communication. Then we have the communication interface actually. This is also same. The communication interface defines the path between devices that do not use the same communication protocol, meaning it includes, computer, modem, printer, all these. So many systems combine the communication, okay, of a peer-to-peer with a polling network. So the polling LAN device can receive data from peer-to-peer devices, but data must flow through the interface. So this is the interface here, which we use for data. Okay, right. Then we have an operator interface. Of course, as you know, operator interface is used to see the data, program the system, exercise the manual control, store long-term data, and dynamic graphic interface. But there are 5 types of operator interface. One is a desktop computer, which acts as an operator workstation. Other is a notebook computer, which acts as a portable operator workstation, and you have a keypad type liquid crystal display tools, and also handheld consoles, palm top service tool, and smart thermostats. These are the operator interface. Okay. Then we go into the protocol. Okay. As I mentioned, okay. So protocol, friends, there are three classification. One is a closed protocol, second is a open protocol, and third is a standard protocol. See, closed protocol is a proprietary protocol used by a specific equipment manufacturer. A open protocol is available to anyone, but not published by a standards organization. A standard protocol is also available to anyone, but it is created by a standards organization. Okay, so that is about the protocol. Okay, basically this is the classifications of protocol. And when we talk about the standard protocol, we have this BACnet. BACnet is nothing but a standard protocol published by standards organization, like American Society of Heating, Refrigerating, and Air Conditioning Engineers, or we call it as ASH or AE. Okay. So when we talk about the BACnet, friends, so basically it's a communication designed for building automation and control system. Okay. So some of the features, maybe we'll talk about features. So features in the sense interoperability. It allows the devices for different manufacturers to communicate, simplifying the system of integration and maintenance. Then data exchange. It enables the exchange of crucial data such as temperature, facilitating efficient HVAC operation and optimization. Then we have a fault detection and diagnostics. We call it as FDD. So it helps in energy usage, determine potential faults before they cause significant problems. Then we have a remote access and control. With proper security measures, users can monitor HVAC devices and parameters for remote location, from a remote location. Then, of course, we also use for energy management, friends. This is about the protocol and especially the BACnet. Then finally, we go into the advantages of DDC. See, speed. HVAC, the DDC system for HVAC has many advantages. One is the speed. Speed means the signal can be sent instantly. Then complex calculation. The computer can work out many complex calculations that a technician might not be able to do because of the time required. Then reliability. The computer always works a problem the same way, so it is reliable and accurate as long as the information fed to is accurate. Okay. Then central and monitoring control. The whole system can be controlled from a single location. This allows the instant operator interaction with the building system and many systems. Okay. Then complex adjustments. A computerized control system receives signal from all the sensors in the system and process all the information at the same time. It instantly computes the best possible setting for the entire system and outputs many different level signals continuously to control the system actually. That is a complex. Then anticipation. See, a computerized control system anticipates what will be needed. For example, if the outside air temperature is extremely hot or cold, system setting will adjust for additional time it will take to bring a space to the desired set point. It will also anticipate the needs when the outside temperature is changing rapidly. Okay, right. Then printed report. A computerized control system may generate all types of reports, graphs to show the trends of the system. This can also be printed as per our requirement. Then improved accuracy. Here, there is a less chance of human error. Equipment is more accurate because there are no mechanical device and no mass, basically weight, such as moving contact points or mercury bulb, all these not available. So this is basically improved accuracy, less chance of human error. And precise control, there is a less time lag between set point and activation. So because DDC use electronic and electronic circuit devices for monitoring and control, right? Okay, then conservation of energy. So basically, that it offers a tighter control of the system. The hours of occupation can be refined and the temperature in the space remains at a more constant level. Okay. So that's about the conservation and sequencing. Okay, second, sequencing. Sequencing provides a proper sequence of equipment startup after the system shutdown or a power failure. Okay, then we have a feedback. So not only sends control signal to the operating system, but also sends feedback and records data concerning the status, environmental condition, and mechanical conditions. Okay, then we have this innovation. So innovation in the sense that it allows the operator to invent additional strategies that can be carried out by the computerized system. Then flexibility. Since the logic of the control loop is in the software, this logic can be readily changed. In this sense, DDC is more far flexible and changing the reset schedule, set points, of the overall control logic. Okay. Then operability and maintainability. See, the alarming capabilities are strong and most system alarms to various locations on a given network. Okay. So the trending capacity as a capability or a technician or engineer to troubleshoot system and control problems is visualized in various formats. This data can also be stored and measure equipment performance over time. Okay, so runtime of various equipment alarms message can be generated when a need change or occurs, or if it is time to conduct a routine maintenance. So all these options are available, friends. That's all, friends. I have this DDC. Hope you have enjoyed this session, and thank you for watching, and see you in a other different video. Okay, thank you. So I'm done with this HVAC system. Thank you. Take care. Bye-bye.